Hello and welcome to this Automation Academy Mastering the Machine webinar for the 1st of September 2023. The subject today was Omron's CXOne PLC programming platform and a little bit on the HMI. Hope you enjoy it. Good morning and welcome to this Automation Academy Mastering the Machine webinar. This is number 62 in a series of about 2 years. And this is the 1st of September 2023. Topic today is Omron CXOne, and this is a suite of PLC and HMI programming software with a whole lot of other stuff, and we'll kind of be going through that. I taught a class this week in Detroit, Monday and Tuesday, very short class for about 4 people. And they really just needed troubleshooting and kind of an overview of the software. So I got to get involved in CXOne again. I've only taught this class one other time. It was about 3 years ago. And I'm not an expert at Omron by any means. My main platforms are Allen Bradley and Siemens, and doing a lot of Beckhoff lately. But I have been digging a little bit more into the software. So I'll explain a little bit about how all that works. So what is the Automation Academy? This is a training website. It's a membership website, and you can find the page where you would sign up for that. If you are interested at automationllc.com, you should be able to navigate into a place where you can sign up. Of course, it does cost a little bit. So if you're on a budget and you can't afford things like that, don't worry about it. There is a platform where you can join up and ask questions, that sort of thing, called IO Central. And that's this little icon right here. You can find it at pretty much the same website. And I do have a blog with lots of free information on it, automationprimer.com. So if you are interested in the Automation Academy, lots of training videos, downloadable files, things like that there. And we do have these events, and these are pretty much mostly open to everybody. Every once in a while I have a private one, but we do these Mastering the Machine webinars about every 2 to 3 weeks. And as I mentioned, this is number 62. So again, today's topic is CXOne specifically. Again, I'm not an expert at Omron. It's not my main platform. But ironically, the first platform I ever learned was Omron back in the early 90s. And I went out to Atlanta and took a bunch of classes on the C200H CV series. And this is exactly what the software looked like. It was DOS based at that time. Windows 3.1 had just come out a year or two before. So they were still using something called LSS, which I remember fairly well. And also they had handheld programmers that you would plug into the PLC, and you would punch in the instructions with little keys, and you would bring up the functions by function number. So things like timers and counters, things like that, standard functions, you would look in the book and figure out what the function number was for that particular function that you wanted to use, and you would type it in. And the context and things like that were done the same way, little icons on the handheld programmers, or you could get into the software and it was much the same as what you see here. So at that time, like I said, the C200H and the CV were the main series of programmers. This is a Japanese platform, so I'm sure the software was converted from the original Japanese and turned into this DOS platform. And then I kind of left Omron behind for a long time and got into Siemens and Allen Bradley and that sort of thing through the 90s into the 2000s. And then, of course, recently got into Beckhoff. So those are really my main platforms. And I hadn't done Omron until a few years ago. The company that I teach for asked me to go out and teach a class in Vermont. So I went up there. It was at the beginning of COVID. I had to do a kind of a crash course on Omron, and I got to experience the CXOne software, and that's what I'll be showing you here today. And the platform that we used in this class was the CJ platform. And if you want to see that, I believe I have an Omron video on the YouTube channel. So you may be seeing this on YouTube. You can kind of navigate to the Omron Odyssey video that I put up there. But that trainer, it's a little suitcase trainer. I'm not sure if you can see behind me here on this webinar, but there are some trainers here. And I build some trainers, but automation training uses these little suitcase trainers, and there is an NJ inside of it. And there are a couple ways to go online with it. One would be there is a USB connection directly, so fairly modern there. You don't have to use a serial cable or anything like that. Or you can use Ethernet. Ethernet, you have to set the Ethernet ahead of time, so you probably would need to have already gone online with the USB and set your Ethernet port up. But once you do that, it's very simple to connect. Probably most people would use the USB port to connect up to that. And then when I go out and teach these classes, I talk to the students and they say, you know, there's a newer platform out, the Sysmax Studio platform. And it's pretty much all tag based. So you may be familiar with that. If you've been on any of these webinars, we talk about Alan Bradley, for instance, has the 500 platform. The 500 is register based. You have B3 registers and N7 registers. Some of you may be very familiar with that. And then there's the newer ControlLogix, and ControlLogix is all tag based, where you just type in a name for a tag and what kind of tag you want to use, you know, an integer, double integer, a real number, or a Boolean. And it just automatically creates that tag in whatever type you want. And that's the way Sysmax Studio works. So I have no experience at all with Sysmax Studio, but it would be the newer stuff. And I'm sure it's a little more expensive, just like Alan Bradley is. For those of you who do Siemens, the old register-based stuff is step 5 or step 7. And they have M registers and they have data blocks and things like that. And you would need to make all of your addresses out of that. And you would have to manage your own addressing, which is the same thing you have to do on this platform. Now, this is newer register-based stuff. It's not anywhere near as old as what you see on the left, the LSS and SSS software, but it is still something that you have to manage the memory yourself. It will not stop you from overwriting things. And for instance, putting a bit in the middle of a word and accidentally changing the content of your tag, which could be dangerous. The newer tag-based stuff, pretty much that all takes care of itself. So those of you who are familiar with Alan Bradley and Siemens, you would know that you can't kind of accidentally destroy your data by putting tags in the wrong place and that sort of thing. Before I get into the software itself, I want to talk a little bit about the registers. If you do Alan Bradley, older register-based stuff, you would know that, for instance, they have registers for a real number or a Boolean, and there's a little bit of overlap between the Booleans and the integers. For instance, I can use a Boolean register and put a number in it. But the bits, or the B registers, are really meant to be used for bits, individual bits. And the N registers are meant to be used for integers. But you can use the individual bits out of the integers. If you've done Siemens, you would recognize that they have a big generic M area, and then you divide that area up as needed, right? You would, all your bools and your reals and your integers and your double integers would all come out of that M area, and you would have to subdivide it up and make sure that you don't accidentally use a bit, for instance, in the middle of a real. That would be a disaster, right? But everything's byte-based in Siemens, so if you need a real, you set up 4 bytes, everything's byte-based, and you just declare a real. But that doesn't stop you from changing it. Well, what you see here is a completely different type of register layout. And if I had to equate it to both Alan Bradley and Siemens, I would say it's like a combination of both. So what you see here in the W's and the H's, these are all word-based. So they're 16-bit based registers. and you can use bits out of them. But whereas, for instance, Allen Bradley, everything is retentive. In Siemens, you assign areas to be retentive. Here, they have the work area, which is not retentive, and then they have the holding area, which is retentive. So when you select your bit addresses, you have to be very careful about what type of bit you're using. For instance, I'm going to show you the software, and if I had put something like my manual and auto mode, even if I had set the bit in the work area, and then I go in and go offline and back online again, that bit will be reset. So if you were in manual mode and you leave the environment, come back in, restart your PLC, whatever, you will no longer be in manual mode. It won't remember what you set it to. So if you have a power outage, that could be a very important thing. So in that case, if I need retentive memory, I would use this holding area. The auxiliary area, these A addresses, are generally associated with the processor itself. So if I need something like first scan, if I need just a pulsing clock bit, something from the internal clock, I would be picking it from this auxiliary area. Temporary relay area, honestly, not too sure exactly what you use that for. I have looked it up before, and I'm sure I could probably tell you if I looked it up, but honestly, I haven't found a major use for it. Some of these other things, same thing. In this program that I'm writing right now, I haven't used any of the task flags, for instance, or these temp relay areas. Whoops, flipped to... There we go. I haven't used any of these temporary bits. Timer, preset value, and complete flags. You can see here, these are assigned specifically to timers. These are assigned specifically to counters. You use the timers much like you would in the older Allen Bradley and Siemens register-based systems. You just pick a number. And so in this little application I'll be showing you, I've used, I don't know, maybe 4 timers, 5 timers. And they're literally T0, T1, T2, T3. And as you can see here, you have 4,096 possible timers you can use. So that's plenty. That's a lot of data registers and things like that. Counters, same thing. These are some of the older style timers. So IEC timers, you're going to be timing in milliseconds, but these older timers, they have a time base, and that's because they were, in general, they were 16-bit timers. So you had to put a base in there if you wanted to get a long time setting. They also act a little more like the Siemens timers. They will time down, and so you'll be done when you're at 0. That's a little unusual, right? Allen Bradley, you time up, and when you hit your set point, then your done bit comes on. That is more like the definition of an IEC timer. So for those who don't know, I've kind of explained a little bit of the history. A lot of these PLCs, register-based PLCs, evolved differently from each other. Modicon and Siemens and Allen Bradley, they all kind of came from a different background and treated things different ways. That's why some timers time up, some time down. But in 1994, the IEC, International Electrotechnical Commission, came out and said, we're going to define what a PLC is supposed to be. And it immediately made all PLCs obsolete, mostly because at that time, everything was 16-bit. And for instance, to be able to get a set point in a timer high enough to use milliseconds, if you had a 16-bit register, the highest you were going to go is 65,000. And then that was further complicated by the fact that most of the integers at the time were signed integers. So there, you can only go to positive 32,767. And of course, that's not a very high timer in milliseconds. You could only go to 30 seconds. So if you wanted an hour on your timer, you had no way to do it other than putting a time base in there. So that is an obsolete way of doing things, but that's the way these old timers worked. They were all 16-bit. The new timers, the IEC timers, they kind of retroactively put IEC timers using double words and things like that into these older platforms. So Allen Bradley does have a version of an IEC timer, and Siemens, of course, has IEC timers. They are function blocks, and you can import them as libraries, but they kind of have to do special special methods of handling those numbers. Other things here, the task flag. I'll be explaining the task and program structure. These are telling you which task is running. So the tasks are kind of treated like programs are in Allen Bradley and Siemens, or routines or networks or whatever you want to call them. It's a little different organization there. And then they divide the tasks up. They're more like programs, I guess you'd call them in Allen Bradley. And they divide them up into something called sections, which are probably closer to what you might know as routines. These last two registers here, index registers and data registers, are used for indirect addressing. So in the data register, you would put an address of a data point or something. Could be physical I/O, could be just data, and then your offset would be placed in the index register. So that would be your pointer. If you wanted to do indirect addressing and say go to data memory location 1000, you might put D1000 in your data register. And then if you wanted to go to D1010, you would put a 10 as an offset in the index register. And that allows you to, for instance, grab ranges of data and treat them as arrays, which again, in the older Siemens platforms, you could easily do arrays, but in the older Allen Bradley platforms, you had no way to do that. You could do indirect addressing, but the only method you had was, for instance, create a integer register and then use pointers for that. So without any further ado, I'm going to go ahead and drag the software over and kind of show you what I've been doing here. And I do most of my training when I teach my own classes. I kind of do things the same way. I have students start out with a basic, well, let's go into something else first. Let's say you have a real PLC and you just want to see if your communication is working and if your PLC is running. So this first line that you see up here, I've got a push button. And if I go to the push button, you can see here, it has a physical address. This is another confusing thing about Omron. This address down here, notice it doesn't say, for instance, W or H. If I go to the push button, it says W. If I go to this manual mode, it says H. So before, when I showed you the registers, the holding registers, right, which are the maintained values, those are the H's. So my modes here are H's and my push buttons are W's. So they're not retentive. I didn't figure I needed retentive values for push buttons because most of the time they're momentary. So if I go up here back to the push button's address is 0. That area is called the CIO area, and all the lower numbers of it are assigned to physical I/O. And that's not an obvious thing here, but when I put my first card in here in the I/O table, let's see how that looks. Go ahead and open that up. And I put a input card in here. It landed at 0. So that is a physical address, CIO area 0. And so if I just type in a number 0.0, I am getting the first input point of that input card. That's a little confusing because there's not an I or an O or a Q or an X or a Y, which sometimes people use to designate that that's IO. It's just a number. So when I go in here and I put 0.00, that's what I'm pointing at as the first push button here. So if I want to test the real push button, I go here and I type 0.00, and this is showing you that down here. That's the address. The name of it is PB1. That is a symbol. And then here's the output. And the output is at 1.0. And so again, when I go to my IO table here, you can see that the output was set to 1. And so these numbers here, 0000, that is the CIO, just register-based address of the IO. That's pretty unusual. The analog works pretty much the same way. This is an analog unit, and its address starts at 2000. And of course, it's a word-based address. So instead of going 1.0, 1.1, I would use the entire register of 2000. And again, not clear, but this this card actually is divided into 10 words, out of which, oddly enough, the input ended up on number 5. And the only way to really figure that out that I found is to simply test it. Go look at your registers and you turn your potentiometer or whatever is on the trainer, and you'll see the number go up and down. And I would have guessed, for instance, it says 2000, that the first address would have been 2000, and instead it ended up at 2005. So the only things I had to test on that unit were the 2 analog potentiometers and just see what the numbers did. So this is not part of the standard programming I do, but it's a great way to test a physical PLC. If you've got one, go ahead and download something with just a push button and a light. And if you push the button and the light comes on, right, and I can actually toggle this because I'm simulating, I'll just set it on, and you'll see here that the indicator came on. That's another very unusual thing about Omron that is very different than Siemens, Allen Bradley, Beckhoff, whatever. I can be in simulation and I can set a physical input. Since I'm simulating, it knows don't go out and read the physical input table for the push buttons and the indicators. Don't write to a real indicator. Go ahead and just write to this address. So what you're looking at here is just the IO table. It's not anything physical. If I had this hooked up to a real PLC and I was online with that, it would look exactly like this, except I could not set my PB1 because I would be reading my input table over and over again, and it would overwrite whatever I had set here. But in simulation, you can do that. So this is a nice way if you're hooking up to a real physical PLC of just running a test. And I didn't delete it, but typically I would, after I've established communications, got my IO working, I would go ahead and delete that. So let's take a look here at the programming environment again. I'm going to set this off. And this little icon right up here says Work Online Simulator. This is a really cool thing that Omron has, that you can simply be typing your code in and simulate it at any time. This is much like the Siemens Step 7 simulator. There's just a little cloud. You open it up and it brings up a little fake PLC, and you are downloading to the fake PLC. So whenever you put new code in, it automatically just downloads to it and runs right in the background. Here, it's almost so easy to do it that sometimes you don't know if you're simulating or you're online with a real PLC, which could be a problem. You might think that what you're looking at is what's in the processor, and that is often not true with Omron. So a little bit can be a little bit confusing there. So I'm looking here at just the coding environment. And of course, if I wanted to put new code in here, I would have to be offline, and I would do this sort of thing. Grab one of these and drag it down here and then put an address in here. And if the address is already in your symbol table, then it will show up right in this list. So I typed P, and it said, oh, you must want to use the first push button that is not being used so far anywhere else in the program. And that happened to be push button 4. And then it gives you the ability to comment it right there. If you change this comment, you'll be changing the actual comment in your symbol table, which might not be a good idea. So it just automatically goes through that step each time, and you can just hit enter here and it will come up. It's red, meaning it's not legal yet. And then you can just set these little straight bars here. I'm going to hit control and the right arrow, and it will add these little bars. It does not fill that in for you like some of the AB stuff or the Siemens stuff. I think Mitsubishi works much the same way as this. And then once again, if I wanted a coil, I would just drop it in there, and I could pick an existing address, or I could make up a new one. I'll just make up a new one here just for fun and show you how that works. Do this. Okay, so I've made a tag name here, a symbol name, And then it says, where do you want to put that, right? What address or whatever. And this is, again, where it's important to understand the I/O structure as to where you're putting things. Do you want this to be retentive? Do you want it to be momentary? Do you want it to be a physical output? If it was a physical output, I would literally be typing in a number here. And I would need to type in a number of something that was already in the I/O table. But in this case, we'll say that I want this to be retentive. So I will set it to one of the holding relay locations. And I haven't used H20, for instance. So H20.0. I'm just arbitrarily picking one bit out of word 20 in the holding register. Now, at this point, it says, do you wish to put this in the local symbol table? So what I've got here is a system program. Each program has its own symbols. Unlike Allen Bradley, these are not truly local. Anything can grab this address from the system routine simply by saying system dot whatever. So it segregates it from the standpoint of being able to organize it and find it. That saves you over, for instance, putting this in the global symbol table, which is this right up here, right? There's the global symbol table. And I'm going to say I want to put it into the global symbol table. So I say no, and now that tag is in the global symbol table. And if I click on it, if I just go up here and select it, you can see down here, do this is assigned to H20.00. And then PB4 is assigned to 0.03, which you would need to just recognize that 0 and 1 are from this I/O table. So when you see something that doesn't have a register assigned to it, it is the CIO area in this. So that's a little bit on the editing. And then if I wanted to run this, again, I would come up to this, and this says Work Online Simulator. And there is another option here, which is Start PLC to PT Integrated Simulation. What this does is this uses an internal server, and it reads and writes from the server, and then things like a SCADA system or an HMI could also read and write to that server, and you might be able to run, for instance, multiple PLCs. So this is pretty powerful for a register-based system. Does a lot of different things. So I'm going to just simulate this, right? Work Online Simulator. Works pretty well. And there I am in you saw it transfer. Let's see if I can find the little PLC and show you what that looks like. There's just a little icon for it. There we go. It's here. So this is what the little fake PLC looks like, right? You're downloading to that, and you can run it and pause it and stop it and do all those kinds of things. So that's the little debug thing. It kind of goes to the background, which I actually like. I don't really like this staying on top all the time like it does in Siemens. It's good that it kind of, if I click here, this should go. Well, actually, it is staying in front. I can always minimize it. So that's a way to get rid of it. Some of the simulators stay in front of everything, and that blocks your view or whatever. So what I'm looking at here, kind of did this little basic simple program. I always do this manual push button, latch manual mode, auto push button, latch auto mode to start with. That's a good way to get students familiar with the editing environment. So here I'm looking at something called a keep. And a keep is the same thing. If you're a Siemens programmer, that's the same thing as the set reset block, which Allen Bradley doesn't have anything like that. They have a latch or an unlatch, but this is one block that keeps your set and reset together. So that's kind of nice. And again, Omron calls it a keep. You got to remember all these instructions would be converted from Japanese. So instead of saying latch, unlatch, set, reset, they just keep, right? That's a way to, they're mnemonic for a holding relay. So you see what happens here. If I press the manual push button and I'm not in auto cycle, then I will set this bit. Now, to make things a little bit easier, I do have my typical auto cycle and all that kind of stuff, my timers and everything. To make things a little bit easier, And I just did this morning. I am new to this whole platform just about. So I actually went into something called CX Designer. CX Designer allows you to build HMIs. And so this is the environment for doing that. And this took a while to learn. It's not intuitive. For instance, if I go in here and I started entering the properties of this push button, I got off on a real tough track here and ended up, for instance, picking the wrong type of device here. You can pick all these different things. And if you pick the wrong one, you see this here, for instance, rectangle type 3, the color changes according to the combination of display address 1 and 2. Some of these other ones have, for instance, a top half and a bottom half, display address 1 upper and display address 2 lower. So I went and configured all this, and it did not at all change colors when I tested it. So, and also the help file wasn't super awesome. So finally, I think I went on YouTube and found something, and I finally was able to pick the right format, right? The right one of these, and also the right one of these. One of the things you want to be careful about is do not click this and put an address in here. That's what I thought you'd do. I thought you'd say, if I want this to be green, putting in, for instance, holding relay 1, which is the address I believe I use for this. You do not do that. Right? You need to unclick that, and then there's another place to set it. So another thing I haven't found, there are a couple of these that I want to change the text when I press the button. In particular, we'll go ahead and show you that. I have a cycle start here. What I would like this to do is when I start, I would like to say cycling, right, instead of cycle start. So for instance, that kind of thing, I'm going to need to figure out where all that is a little bit later. But the good news about all this is it's pretty inexpensive software, and a little secret here for those who are watching this on YouTube or whatever. There are multiple places where you can get this for free. I don't know that the place you're getting it from is totally legally distributing it for free. So you got to kind of take it with a grain of salt. But I actually did download it and test it. I got version 9.7 from a place called PLC, the number 4 me, PLC 4 me. That website has been around for a long time. It's a blog and a PLC type website, and they let you download it. And you're getting a pretty modern version of it for free. I don't know how they do that. I don't know whether Omron is okay with that. This is an older software platform, so maybe they're fine with it. But you can get all this, the designer, the CX programmer, you can get all this for free. And I did put a copy of it on the Automation Academy site. So if you're a member at the Automation Academy, you can also go there. But I'll just freely tell you, go to plc4me.com directly, and you can download it from there. Or if you join the Automation Academy, it's one of many, many, many files in the library. And I put it under the PLC Omron folder in there. So pretty neat stuff. The designer is the HMI software. The programmer is the PLC software. Show you one other thing here. If I were to open the software, I would browse down to it. And this is kind of an odd way to do things. Go down to Omron. And what you get when you open this is a folder, CXOne, and they're CX server. So there's a lot of things in these folders. But when I press this, instead of this being an icon, I get, you guys can't see it, I get this. So you can see motion control, designer, drive, all this stuff shows up here. Protocol, I would imagine protocol has to do with different communication things. A separate simulator, I messed with this. Do not get in here and try to use that. Just press the little button and say simulate. Not sure what designer, NV designer is, but all this, if you wanted to start, CX designer, you would simply open this up and there's your application. And you could drag this to your desktop and run it also. So all these things are just in these folders directly. There's Programmer, CX Programmer. You could put this on your desktop. So that's the way the choosing the software works. Okay, so we're simulating here. I'm going to go ahead and show you how the designer works. If I want to push some buttons, there's CX Designer. And all I need to do to test this, I messed around with the simulator and tried to do a lot of things at once. And then I looked online and it just said, go here to Tools and hit Test. And it says, how do you want to test? I could do it offline and it would just change colors but not be connected to PLC. I could test it connecting to a real PLC, or I could connect to the simulator, which is what I'm doing here. And there it is. It actually opened on a different screen, but there it is. So this is the actual running software here. If I want to go into manual mode, I would have to do a cycle stop. There we go. I'm cycle stopped. This is one of my basic lessons I do whenever I teach PLCs, right? If you're in auto mode, but not in auto cycle, go ahead and blink this light. It gives students an opportunity to create some timers and things like that. Then you can go into manual mode. And if I go into manual mode, light the yellow stack light. So very simple code. You can have this running and look at Programmer and kind of bring this to the front if you wanted to test it. And that way you can see things like go from auto, right? You can see switch to auto here and to manual. So you hold it on, you can see the button lit. Typical, code viewing. So pretty good software. Auto cycle, go into auto mode, hold the cycle start button, you'll see the timer run. So this is a BCD timer. We can get off into that a little bit later. I have some instructions if you don't understand what BCD is. There it's timing, it goes down to 0. You saw it count here. We'll do a cycle stop again so you can see it again. Watch this number and you'll see this timer time down. That's 3 seconds. 1, 2, 3. It counted backwards from 30, and then the done bit came on, and the done bit fires a sets the cycle auto cycle bit. So when T0 goes done, then I set. So set and reset are your typical structures, just like you have an AB and Siemens with a set and a reset, or a latch and an unlatch. But you have the ability to just put these keeps in here also. So those are different ways to do it. So there's a timer, there's a latching bit, there's a set and reset. Then your lights, I went ahead and put these in a separate place. I put them in the outputs, double click it, you get the outputs here. And I said, if you're faulted, light the red stack light. If you're in manual mode, light the yellow stack light. And then this is how I blink. To make this blink, I actually put this simple little, you can find this online pretty much everywhere, simple little reciprocating timer, because when I tried to use the pulse timers that they had in there, they were too fast. So there are lots of internal tags that you can use. I'll go ahead and show you some of those. Here's my symbol table. And you can see here, these internal tags, CF, C flag, I believe, greater than or equal to flag. You have some pulsing bit flags. Up here, this is kind of interesting. You can see all these A bits that we talked about before in those registers. These are the auxiliary bits. A402.08, cycle time error, that's a processor type function. So these are tags that are built in, and then these are tags that you can put in. So if you want to add a tag, you just right click and say insert symbol. Of course, you have to be offline to do that. So that is a look at the software. As I mentioned, you can get it free online at various sources and at the Automation Academy. or at PLC for me. And to install it, you literally use the password PLC, the number for me, and it works. I have verified that it works. I do have a licensed copy. I have just one, but I went ahead and verified that works, and I did put it in the Academy site. So that's a little bit of a look at all of this. There is a whole lot more, right? We could talk about the structure of this. Something fun I did. Let's go ahead and show you that. This was a little more elaborate. I did write a function block. I ran a runtime, which is another basic thing that I do in classes a lot of times. And I generated the time that you are in auto mode, and I let it run last night. And so I'm at, let's see, 16 hours of runtime since yesterday. You can see here it counting up. And this is a typical data collection technique, right? I know how long I've been in auto, how long I've been in manual, an hour and 34 minutes, and how long I've been in auto cycle, which is only 1 hour. This morning I started running this auto cycle. So this is a fun thing to do too. You can open up these function blocks and see how they're built. Function blocks, everybody hopefully knows what those are. This is the code inside of it, and it is a reusable block that I can use over and over again. And then I would have to take it an instant at a time. This is not the way I would normally program it, but I couldn't figure out how to use the timers inside of it. So I used one of the internal 1 second pulse bits, which is this device with a 1 second one shot. And then use that to count minutes. Then minutes cascades into hours, right? So seconds cascading into minutes, cascading into hours. Typical function block for that. Again, lots of places you can find that kind of stuff online, and I usually throw those into my classes. People like that because runtime on everything for data collection is very useful. So pretty standard way of doing things, but that's a look at the function block. And I do have a little scaling block here, and they have libraries and lots of other stuff also as needed. So that's a look at the CXOne software. And not sure who all might be here watching, but if there are any questions, comments, questions. So that is most of today's material. CXOne, again, pretty good stuff. You can get the software from PLC for me. You can get it from, oh, Phil's here. All right. Hey, Phil, how you doing?
Hey, I'm hanging out. Always a good time.
All right. Yep. So the next webinar, September 16th. And the main reason for that, I'm leaving on a long drive to the Northeast US, and so can't do it the following week. Otherwise, I might have given it a little more time. I have no idea what the topic will be. We'll just make something up. And, you know, this is probably it for platforms right now, because I'm going to be back to doing lots of Alan Bradley and Beckhoff, and we've done that lately. I am doing a webinar for those interested on Control Engineering Magazine on the, I want to say it's the 15th. So it's the day before this webinar. I think that's a Thursday. And so for those of you that get Control Engineering Magazine, CFE Media, somehow they couldn't get other guests in addition to me. So I'm doing the whole thing myself, and I'll be talking about comparative PLCs. So they don't like you mentioning specific brands, but we're going to treat it as A, B, C, and D, right? Brand A, brand B, brand C, brand D, and you'll be able to figure out which brand is which pretty easily. But that's the way we're going to refer to them. And I'm going to be talking about comparing all those old register-based PLCs and all the newer tag-based PLCs, and why it's kind of hard to learn one platform if you know another platform, even if it's tag-based, some of the differences between those platforms. So I'm going to be spending their full 40 minutes, and I think it's sponsored by somebody like ABB, but they do these, I think, monthly. And I've been on them before. It's been a year or two, but this time I was the only guest they could get. So you're stuck with me. But anyway, that is the end of this webinar. Again, sponsored by the Automation Academy, which once again is me, IO Central, which once again is me. And if you are interested in joining the Automation Academy, feel free to sign up at automationllc.com and catch this on YouTube. Just go to Automation Consulting LLC on YouTube and you'll see all these other webinars. Again, this is number 62 in a series of about 2+ years. So thanks a lot for hanging out.